Let's take a closer look into how DNA replicates. The process by which DNA makes a copy of itself during cell division, how each new cell gets all the genetic material, how it is copied so that when one cell divides, each resulting cell keeps a copy of all their chromosomes. This process is called DNA replication. So, how does it work? Imagine that DNA replication is a computer game. And in every computer game, we have characters or players, right? Now, let me introduce you the key players of the game. We have helicase, the unzipping enzyme, the DNA polymerase, the builder, the primase, the initializer, the ligase, the gluer. DNA replication starts at a point of origin. This part is identified by certain DNA sequence. We describe DNA having two strands, and what helicase do is to unwind the double helix and disrupts the hydrogen bands between the bases, thus separating DNA double strands into individual strands and creating a replication fork. The unwinding of the helix generates torsional strain in the further head of the chain. As we go on, topoisomers break and twist and reconnect the DNA always ahead of the replication fork. When the strand separates, we can now begin copying each one, but take note that the enzyme that copy the strands need a place to start. So the enzyme called primase will anneal an RNA primer to a specific location to start the replication. Primase make the primer so that DNA polymerase can figure out where to go and work. This primer is made up of RNA with 5 to 10 nucleotides long. DNA polymerase III, the builder, binds the primer and begins generating a whole new complementary strand, adding nucleotides to the new chain that was initiated earlier by our primer. DNA polymerase III catalyzes formation of the phosphodiester band that join each new nucleotide as it is added into the complementary strand. And don't you ever forget that each strand of DNA double helix runs in opposite direction, or simply they are anti-parallel.